New on CuriosityStream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
Big decisions require research. So if your teenager is considering a decision as big as joining the military, they're doing their homework. You can too, by visiting todaysmilitary.com, because their success tomorrow begins with your support today.
This is SpaceTime, Series 24, Episode 16, for broadcast on the 15th of February 2021. Coming up on SpaceTime, purported phosphine in Venus, more likely to be ordinary sulphur dioxide, the mystery of the Jovian Trojans, and the growing Starlink problem for astronomy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that last year's observations of phosphine in the clouds of Venus was actually just sulphur dioxide. The initial claims of phosphine made headlines across both the scientific and wider community. Phosphine's a compound made of phosphorus and hydrogen, and on Earth its only natural source are tiny microbes that live in oxygen-free environments deep inside remote caves. The apparent discovery of phosphine in the acidic clouds of Venus can't be explained by any known chemical or geological processes, and that suggests a biological origin. In other words, there must be life in the clouds of Venus. But since that initial claim, other scientists have been questioning the findings. Now, a report in the Astrophysical Journal and on the pre-press physics website archive.org claims what was detected wasn't phosphine, but rather sulphur dioxide, a compound much more in keeping with the thick sulfuric acid composition of the thick Venusian cloud cover. In fact, sulphur dioxide is the third most common chemical compound in Venus's atmosphere, and it's not considered a sign of life. So, what happened? Well, back in 2017, the authors of the original study were using the James Clerk Maxwell telescope in Hawaii when they discovered a feature in the radio emissions from Venus at 266.94 GHz, a frequency near which both phosphine and sulphur dioxide absorb radio waves. To differentiate between the two, the original authors obtained follow-up observations in 2019 using ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile. Their analysis of the ALMA observations at frequencies where only sulphur dioxide absorbs suggested that the atmospheric sulphur dioxide levels there were too low to account for the 266.94 GHz signal, meaning it must have come from the phosphine. But the new study, led by Andrew Linkowski from the University of Washington, developed a far more detailed model of Venus's atmosphere. They used data from decades of observations using both Earth and space-based telescopes, as well as visiting spacecraft such as Venus Express. The new model was then combined with the ALMA and James Clerk Maxwell telescope datasets to reinterpret how sulphur dioxide and phosphine signals would be picked up. They found that the original signal originated not from the planet's cloud layer as originally thought, but 100 kilometers higher up in the Venusian mesosphere, where phosphine molecules would be destroyed within seconds by harsh chemicals and ultraviolet radiation. This is SpaceTime. Still to come, the mystery of the Jovian Trojans and the growing Starlink problem for astronomy. All that and more still to come on SpaceTime. A new study claims Jupiter's Trojan asteroids may be a lot stranger than originally thought. Trojans are objects orbiting in a planet's L4 and L5 Lagrangian positions. Lagrangian points are named in honour of 18th century Italian-French mathematician Joseph Louis Lagrange, who was working on the general three-body problem in orbital mechanics. You see, there are points in space where the gravitational pull of two bodies, such as, for example, the Sun and the Earth, or the Earth and the Moon, tend to cancel each other out, while equaling the centripetal force needed for a small object to move relative to the two larger bodies, and so allowing that smaller object to remain there for an extended period of time. The L1, 2 and 3 positions are along a straight line connecting the two primary bodies, say the Earth and the Sun. Now, in that case, L1 would be between the Earth and the Sun. It's often used by spacecraft needing an uninterrupted view of the Sun, such as the Solar and Heliospheric Observatory spacecraft SOHO. The L2 position is on the opposite side of the Earth to the Sun. It's home to spacecraft like Planck and the soon-to-be-launched James Webb Space Telescope. That's because it's an ideal location for astronomy, as spacecraft are still close enough to communicate with Earth and can keep the Sun, Earth and Moon behind them for solar power while still providing a clear deep space view for telescopes. The L3 position is on the opposite side of the Sun to the Earth. Because the L3 point's always hidden from Earth by the Sun, it's become popular in science fiction and some conspiracy theories as a location for a hypothetical second Earth. Then there's the L4 and L5 Lagrangian positions, the ones we're interested in here. They provide stable orbits around 60 degrees ahead and behind the Earth as it orbits around the Sun. And it's in these orbits where Trojan asteroids are commonly found. And the same goes for Jupiter, where large swarms of rocky asteroids populate these positions, sharing Jupiter's orbit as it circles the Sun. The L4 group of asteroids ahead of Jupiter is slightly larger than the L5 trailing group of asteroids. But until now, astronomers have always thought there was little difference between the two swarms. However, new observations by ATLAS, the Asteroid Terrestrial Impact Last Alert System, which is based in Hawaii, has unexpectedly discovered that the L4 asteroids are on average more elongated in shape than the L5 population. The study's authors speculate the difference could have been caused by a different collisional evolution within the two clouds. The larger L4 population may simply have resulted in its asteroids having more opportunities to smash into one another. And so, after billions of years, larger objects are worn down and battered into more eccentric shapes than those in the L5 group. The observations and hypotheses will be explored in more detail by NASA's Lucy mission, which will now launch in less than a year on what will be a 12-year journey to the Jovian asteroids. The spacecraft, which will be the first to explore the Jovian asteroids, is now in its final stages of assembly, with the last of its 3 primary science instruments now installed. The final instrument, LaRalph, was built by NASA's Goddard Space Flight Center in Greenbelt, Maryland, and was received at the Lockheed Martin facility in Colorado just a few days ago. LaRalph's the most complicated of the 3 instruments to fly on Lucy. It includes a multispectral visible imaging camera to take visible light color images of the Trojan asteroids, and a linear Electron imaging spectral array, which will collect infrared spectra on the asteroids. Combined, they'll allow Lucy to determine the composition of the Trojans, and in the process provide new insights into the early history of our solar system. Lucy's other 2 scientific instruments, the TESS, which was designed and built by Arizona State University, and LaLaurie, which was developed by Johns Hopkins Applied Physics Laboratory, together with 2 terminal tracking cameras, have already been installed on the spacecraft. This is SpaceTime. Still to come, the growing Starlink problem for astronomy, and Rocket Lab demonstrates new orbital maneuvering capabilities. All that and much more still to come on SpaceTime.
New on CuriosityStream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Elon Musk is now officially the world's richest person, with a net worth of $185 billion and an empire that stretches from SpaceX rockets to Tesla electric cars. But one major area of controversy which Musk has so far failed to deal with is the scientific damage being caused by his growing constellation of Starlink satellites. Starlink could eventually include some 42,000 satellites, providing low-cost, high-speed broadband internet connectivity across the entire planet. But this ever-growing constellation, as well as similar ones planned by OneWeb and other companies, are proving to be a major problem for astronomers. Important scientific research is now starting to be affected by what astronomers are calling trains of Starlink satellites constantly crossing the sky. The light reflected by these spacecraft and the radio frequencies they're operating at affects both optical and radio telescope observations. The satellites are incredibly bright, appearing as a train of bright dots as they orbit, and they're destroying science's view of the skies. To try and address the problem, SpaceX has launched DarkSat, an experimental Starlink satellite with an anti-reflective coating. And they've asked astronomers to assess how much this coating is reducing satellite reflectivity. Initial measurements suggest the dark coating's providing around a 50% reduction in brightness. Jonathan Alley, the editor of Australian Sky and Telescope magazine, says only time will tell whether that's enough.
At the moment, it's not a huge problem because they've only got about 700 or so satellites up there. But they've got approval for, I think it's over 12,000, and they have ambitions to have over 40,000 for Starlink. And there's another constellation that another company wants to put up as well, and they too have ambitions for another 40,000 satellites. And there are a couple of other companies that also want to put up constellations of satellites smaller than those, but you're looking at tens and tens and tens of thousands of satellites up there. So I know the calculations have been done by some professional astronomers that indicate that for certain observatories, certain times, there will be 500 of these satellites within view at any particular time. And this really does have the potential to really ruin professional astronomy from the surface of the Earth. Amateur astronomy is one thing, it's going to affect things a bit, but professional astronomers are doing work. They're doing science, they're doing important stuff, and it can have a really, really big effect. I know that SpaceX supposedly are testing some techniques to try and minimize the problem
painting
by
it black.
Putting some coatings on and tilting it a different direction, that kind of thing. But when you've got 40,000 of them up there, I think no matter what you try and do, it's going to have a big effect. So it is of concern for sure.
And the other problem, I guess, also is that with that many satellites up there, the threat of a collision at some stage, either with another satellite in the same constellation or with a piece of space junk, that's got to be a concern.
Yeah, it is. They're going to have, I think, 2 or 3 shells of satellites at different altitudes above the Earth. I can't remember the exact altitudes.
I think 380, 580 and 1,110 or something like that.
Yeah. Keep them in sort of 3 different levels. So look, they say that they're going to take measures to minimise the potential for collisions between the satellites and with other things. But best laid plans. If you've got 40,000 satellites up there, something's going to go wrong. For sure. You're going to lose control of one, lose contact with one or whatever, and you only need one to hit another one, and then it's on for young and old.
Then you've got the cascade effect, which is sort of the worst-case scenario that scientists have been warning us about.
It's called the Kessler syndrome. It's where it is basically a chain reaction. You know, one thing smashes into another thing, you get lots of little bits coming off it, and they all smash into other ones, and they all smash into other ones, and you've got a chain reaction going. And before you know it, then you have a whole orbital altitude of, say 500 kilometres above the Earth, which is just flooded with space junk, and it would be too dangerous to fly through it, to go through it.
The opening scene of the movie Gravity best describes that, if without exaggeration. That's what it's going to be like. A
huge swarm of stuff, coming flying at you like shrapnel.
Yeah.
So that is something to avoid for certain. It's basically pollution in space, but it wouldn't preclude you from flying through, say, if you had a Kessler syndrome kicked off and you had, at say 500 kilometres altitude, just swarm all around the planet of space junk, you could still try and get through, and chances are you would get through, but every now and then you'd get hit. So you wouldn't want to risk that with people. You could do that with unmanned satellites, of course. So when the geostationary satellites that are up there at 36,000 kilometres above the Earth, when they need to be replaced with new ones, well, if every second one's getting hit by space junk and being destroyed, it's going to cause an awful lot of problems. So, the Kessler syndrome is very, very worrying. And I know that there are more moves afoot now to have to put in place more sort of space air traffic control, if you like, to have all the parties talking to each other better and more, and having predictions of where the satellites are going to be, and tracking everything, and trying to work out, how to avoid colliding with each other.
A lot of that would require space law that everyone agrees with, and not everyone's following space law at the moment, for what space law there is.
Yeah, well, the space law is not very, very tough. I mean, there are laws up there. There are not laws up there. There are laws that govern what should be done up there, but,
well, we've had China, we've had India both explode satellites up there.
That's right. And look, so what's going to happen? So someone does something wrong up there, and then it takes 10 years to get through the courts. Meanwhile, it's got worse and worse and worse. The solution is to try and prevent the problem in the first place. And I know that, say, satellite manufacturers and rocket manufacturers have been taking some steps over the last 30 years or so. For instance, in the early days of rocketry, they'd send something up and they'd release a satellite, and the sort of nose cone, if you like, the shroud that was over the rocket, inside which the satellite sat, would burst open and free the satellite, and you'd have springs and bolts and bits of broken metal and stuff flying off in all directions. So these days they try and minimise the release of any bits and pieces, but it's not perfect. And the more you put up, of course, the less perfect it's going to be. So with two companies talking about potentially 40,000 satellites each, and others their own multi-thousand satellite, you're going to end up at 100,000 satellites up there if all this comes to pass. So it's a problem.
Right now, without those Starlink satellites, there are only about 1,500 operational satellites in orbit.
That's right. Yep. And most of those are very large ones and well controlled, and a long way away from each other and kept away from each other. But 1,500, you go from that to an order of magnitude more, to 40, 80,000. It's just the service that they intend to provide. So the SpaceX one, for instance, the whole purpose of that is to provide very low cost, high bandwidth, broadband internet coverage all around the world. That's its purpose. You know what? You actually know why Elon Musk is doing this? He wants to do this, put this huge satellite, constellation of satellites up there to provide, the satellites are very cheap and you can just mass produce them.
About 240 kilograms each, so they're not that big.
Yeah, they're very tiny, but they're in low orbit and with the fantastic electronics now. So what will happen is they'll be sending signals up and down between base stations on the ground, and there'll be thousands and thousands of base stations all over the world. And the internet will connect into those base stations, and so it will provide connectivity from this side of the world to the other side of the world through these satellites, and make the internet really, really cheap, particularly for developing countries and even developed countries like the United States in rural areas where they don't have good coverage,
And it's not just ground to satellite, it's also satellite to satellite laser coverage as well.
Yeah, so they can just cover the whole planet with this internet connectivity.
Indeed.
And he aims to make tens of billions of dollars out of it, and that's the whole purpose, because he wants to put those tens of billions of dollars towards his plan to send people to Mars. He wants to use this to fund this to go to Mars.
And he's working on that too. We've just had another test of the Starship prototype. I prefer calling it a test article because it doesn't look anything like Starship yet. It's just a silver tube. That's about all they've
It's just
got.
a big silo, isn't it? Yeah. Pretty
so
clever stuff.
He hopes to actually have a prototype Starship orbiting next year. And once that's achieved, then he's halfway there. I mean, the ultimate plan is launch 150 tons of people cargo into orbit in one go and 100 tons on interplanetary missions, including, and I'm using his term now, interplanetary colonial transport missions, which is what he's talking about.
That's right.
And that's all because he's concerned that the human race has all its eggs in the one basket, and he wants the human race spread over at least 2 planets.
Well, it's certainly a nice thought, and if it works, it'll be a good thing. There's certainly sort of no harm in that sense in having another basket to put some of your eggs, as long as we don't mess up Mars the way we've messed up Earth, and I'm sure we will. But of course, going to Mars isn't going to solve the ills here on Earth. It'll just mean there are some people over there that maybe will be able to carry on if something bad goes on here.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. Still to come, Rocket Lab demonstrates its new orbital maneuvering capabilities, and later in the science report, the World Health Organization says it's been unable to determine where the COVID-19 virus originated. All that and more still to come on SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Rocket Lab has successfully launched its 18th Electron mission and its first for 2021, in the process demonstrating an improved orbital maneuvering capability. The Another One Leaves the Crust mission blasted off from the company's Launch Complex 1 on the Mahia Peninsula on New Zealand's North Island east coast, carrying the 50-kilogram OHB Group GMS-T telecommunications satellite.
Another One Leaves the Crust is the first mission in a busy launch manifest for Rocket Lab in 2021. This year we'll be launching multiple dedicated and rideshare small satellite missions for both government and commercial customers. It's also the year we'll be launching to the moon for NASA with our capstone mission, which will see us use Electron and Photon to transport a satellite to lunar orbit in support of the agency's Artemis program.
We also have 2 new pads to debut this year. So we'll see liftoffs from Launch Complex 2 in Virginia, as well as our newest launch pad, LC-1B, located at Launch Complex 1. And of course, we'll be continuing our program to make Electron a reusable launch vehicle, with even more recovery missions planned this year.
Minus 10, 9, 8, 7, 6, 5, 4, 3, engine start.
Propulsion is nominal. Guidance is nominal.
And with that, Another One Leaves the Crust. Electron has successfully cleared the pad at Launch Complex 1 and is on its way to orbit. We're now at 46 seconds into flight of our 18th Electron mission and approaching one of the first major milestones of any launch, Max Q, or maximum aerodynamic pressure. This is the moment during launch when the forces against Electron are at their peak. We'll be coming up to that very shortly, so let's listen in.
Approaching Max Q and cleared Max Q.
And we just heard the call there. Electron has cleared Max Q. The Stage 1 burn is performing nominally, and Electron's trajectory is looking good.
Stage 1 guidance remains nominal.
AOS Chatham Station. Stage 1 propulsion is holding nominal.
Shortly, the 9 Rutherford engines on Electron's first stage will shut down. We call this main engine cutoff, or MECO. Right after that, Electron's first and second stages will separate, and the vacuum-optimized 10th Rutherford engine on the second stage will ignite.
Stage separation confirmed.
Stage 2 ignition confirmed.
You heard the good news there from Mission Control. We've had a successful main engine cutoff, separation of the stages, and ignition of the Stage 2 Rutherford engine. Up next will be the fairing jettison. And there they go. There's clean separation of those halves for the fairing jettison. Electron's second stage is continuing nominally as we approach battery hot swap in the next few minutes, a manoeuvre unique to the Electron rocket.
The operations team is tracking no issues, and the burn of the second stage engine is continuing nominally.
Beginning to throttle down. Stage 2 guidance is holding nominal, 200 seconds remaining.
We're quickly coming up to battery hot swap on Electron's second stage. Our Rutherford engines are fed by electric pumps, which drain the power of the batteries during flight. Once the first set of batteries on Stage 2 is depleted, we switch them out and get rid of the old ones we no longer require. The battery hot swap is scheduled to occur just over 6 minutes into the mission, and we're coming up on that very soon.
Battery jettison confirmed.
Hot swap successful.
We've had confirmation that battery hot swap was successful on Electron, and second stage propulsion is continuing nominally. We're just a couple of minutes away now from Stage 2 engine shutdown and separation from the kick stage. Electron is currently travelling at speeds of over 16,000 kilometres an hour and at an altitude of more than 300 kilometres. Soon the Rutherford engine on the second stage will throttle down before shutting off completely to allow for clean separation of the stages. We call this SECO, or second engine cutoff, and this separation of the stages will place the kick stage in an elliptical orbit around Earth for a coasting period of around 40 minutes or so. After that, the kick stage's Curie engine will ignite to circularize its orbit around the planet before the payload is deployed.
Guidance is in terminal, 25 seconds remaining.
There we go. Right on cue.
Nominal transfer orbit achieved.
And there's the call from Mission Control. The Rutherford engine on the second stage has successfully shut down as planned, and the kick stage has cleanly separated.
After separating from the Electron's second stage into an elliptical transfer orbit, the Curie engine-powered upper kick stage performed two separate engine burns. The first raised the payload to a higher than usual 1,200 km high circular orbit for deployment. Most Electron missions target a 500 km high low Earth orbit. After the satellite was released, a second engine burn was initiated. This one to lower the kick stage's perigee so it would deorbit quicker, thereby reducing the amount of orbital space junk. The two manoeuvres meant the 3D printed Curie engine completed more than 267 seconds of total burn time. That's more than twice the standard kick stage mission profile to low Earth orbit. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The World Health Organization says it hasn't been able to determine where the COVID-19 virus originated. But the UN body, which a year ago insisted that there was no human-to-human transmission of the deadly virus and that the Chinese government had the epidemic well under control, now says the Wuhan Institute of Virology was unlikely to be the source of the deadly pandemic. World Health Organization advisor Jamie Metzel says the actual investigation was mostly done by Chinese authorities, with WHO investigators receiving reports from Chinese officials. Investigators were given a 3-hour tour of the Wuhan Institute of Virology and were allowed to speak with staff under supervision by lab management. The Chinese government was quick to promote the findings, saying the virus probably came to Wuhan from bats through an intermediary species in frozen food from India. However, it failed to provide any evidence to support the hypothesis. The Communist government had previously claimed the virus was spread by US soldiers who had visited Wuhan, or by Italians, claims strongly denied by both the United States and Italy. The new claims as to the origin of the virus can't explain why the virus wasn't reported anywhere else in the world until weeks after it was first reported in China. The COVID-19 pandemic was first recognized in Wuhan in mid-November 2019, when large numbers of people with a new variant of the SARS-CoV-2 coronavirus began showing up at local hospitals and medical centers. Beijing immediately sent People's Liberation Army biological weapons experts to supervise a full forensic cleanup of the Wuhan Institute of Virology, which included the removal of all experiments and samples at the Bio-Level 4 facility and the destruction of all notes and records. As the disease spread and the death toll rose, local journalists and medical staff who raised concerns about the deadly virus suddenly began being arrested, and many disappeared. The best known of these whistleblowers was 34-year-old Wuhan medical doctor Lai Wenliang, who was detained by Chinese authorities and forced to sign a confession apologizing for causing unnecessary public alarm. A short time later, he was found dead, government officials saying he died of COVID-19, although there's no independent verification of this. By mid-December 2019, officials began locking down vast areas of Wuhan, even welding shut doors on people's apartments. The communist government also banned travel from Wuhan to other areas of China, but they continued to allow international travel, which quickly spread the fatal disease globally. Claims that COVID-19 originated at the Wuhan Institute of Virology were first raised by US Secretary of State Mike Pompeo, who said there was enormous evidence that the coronavirus had come from Chinese labs. However, a study in the journal Nature Medicine found no evidence that the virus was invented in a laboratory. Then, over the months following that study, reputable sources began questioning the original conclusions. The most important of these was Chinese government virologist Dr. Lai Mengyang, who claimed that the virus was bioengineered from the SARS-CoV-2 virus. She reported her findings on the open-access digital platform Zenodo. Her allegations destroyed her career, and she was forced to flee China for her own safety. Then an investigative report in the Daily Mail Online claimed that while the live animal wet markets in Wuhan, where exotic animals are sold for food, was blamed as the epicenter for the outbreak, the source of the virus was the Wuhan Institute of Virology, which was set up to research the world's most dangerous viruses after previous leaks of the SARS virus from other Chinese labs. Meanwhile, 2 new reports have now been released about the efficacy of the Pfizer-BioNTech and Oxford-AstraZeneca vaccines against new, more virulent strains of COVID-19. The findings, reported in the journal Nature Medicine, suggest the Pfizer vaccine is shown to neutralize both the United Kingdom and South African variants of SARS-CoV-2. But reports of an early trial, which is yet to be peer-reviewed, warns that the AstraZeneca vaccine has only 10% efficacy against the South African strain. Some 2.4 million people have now died from COVID-19, and another 108 million have been infected. A new study has found an almost 2-point decline in IQ levels associated with teens who frequently consume cannabis. The findings, reported in the journal Psychological Medicine, also shows that adolescent use of cannabis is associated with poorer mental health outcomes, including an increased risk of mood disorders, self-harm, and suicidality. The study included 808 young people who had been using cannabis at least weekly for a minimum of 6 months, and 5,308 young people who have not used cannabis. Cannabis remains the most frequently used illicit substance in the world, with the prevalence of lifetime cannabis use highest in young people. Scientists have discovered what may be the smallest species of lizard ever found. The tiny reptile, named Chameleon brookesia micra, is less than 2 centimeters long. The discovery, published in the journal Scientific Reports, was made in the rainforests of northern Madagascar. The unholy alliance between anti-vaxxers and anti-5G conspiracy theorists has reached a sour note, with an expose claiming to provide proof of advanced 5G nanobot technology inserted into a COVID-19 vaccine, turning out to actually be a schematic diagram for an electric guitar foot pedal. The pedal, known as the Boss Middle Zone, is designed to create guitar distortion. The only way it could possibly be inserted into a vaccine would be if the vaccine was administered as a rather light suppository. And even then, there'd be a cable, not 5G. Tim Mendham from Australian Skeptics has all the details.
Conspiracy theorists, as we know, sort of tend to like to grab every bit of evidence they can, even when they're not very good evidence. This one was a particularly classic case where they reckoned they had found, some anti-5G people reckoned they'd found a schematic, like a circuit board type schematic,
circuit diagram,
of a 5G, circuit diagram, thank you, of a chip that was going to be inserted in people through 5G. Now, it was interesting because, they published this diagram. Now, it'd be very difficult to insert it because this is actually the circuit diagram for a foot pedal for an electric guitar called Metal Zone, which is designed to create major distortion, and it's been described as awful. So it uses physical diodes and things like that. I'm not an electrical person, but I have to take their word for it. It'd be almost impossible to stick that in you without you noticing. It'd be like
I guess it depends where you shove it.
Yeah. Well, if they're going to do it through a vaccination, I can't think of how else it's supposed to be inserted in you.
That's what this is all about. This is part of this conspiracy theory idea that if you get vaccinated for COVID-19, they're going to be putting nanobots inside you. That's what this is all part of. And those nanobots use 5G to communicate with each other and, of course, with those at Microsoft or whoever's in charge of the nanobot invasion. Skynet. Let's call them Skynet from the Terminator.
I could see sort of Bill Gates sitting there monitoring every nanobot.
Poor Billy. He gets blamed for everything, doesn't he?
He does, doesn't he? Yeah, the poor man, and he gives billions to charities, but because he gives it to vaccines, etc., he's obviously evil. But this thing was typical of conspiracy theories. It's one of the more ludicrous ones, but it is typical. Because anything that there is actually a reference to a 5G chip in there, but it's got nothing to do with sort of these telecommunications and things. And it's just weird that any bit of evidence like a magpie-like is grabbed and included in that conspiracy theory, and there's no discernment into how they use their evidence. And this thing coming from a distortion pedal for electric guitar is just so silly.
If you're one of the people who have received this information from your conspiracy theory friends, what should you be thinking about those conspiracy theory friends of yours now?
Yes. Don't call me, I'll call you. It's just, the fact that it was exposed very quickly shows that in this day and age, you really can't get away with some of these stranger theories and suggestions. And this one was just, I think they took it seriously. They really believed that it was a genuine sort of circuit diagram.
This is the proof we've been waiting for. This is it.
That's right, yeah, the smoking gun sort of thing. But it was debunked very, very quickly, and they were made to look like a fool, and the trouble is they will continue to do it and find the next bit of conclusive evidence and smoking gun.
Well, that's the thing.
And basically the rule is treat them with a heavy dose of skepticism.
Disprove their theory. That's okay. They've already moved on to the next theory, which is just as preposterous.
Yeah, they have. They're nothing if not resilient, but you've got to keep on them and keep them jumping. Yeah.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
With Miller Mott College's online programs, you can choose when you study. Our online programs give you the flexibility to make education work with your schedule. Earn your degree without derailing your life. Visit us online at miller-mott.edu. That's miller-mott.edu.